Hello everyone, we'll continue our discussion with paper 2. Now we'll start discussing section 2. Let's start with the question number 5. The question number 5 says a positive point charge 10 to the minus 8 coulomb is kept at a distance of 20 centimeter from the center of a neutral conducting sphere of radius 10 centimeter. The sphere is then grounded and the charge on the sphere is measured. The grounding is then removed and subsequently the point charge is moved by a distance of 10 centimeter further away from the center of the sphere along the radial direction, taking 1 by 4 by epsilon naught value to be this. Okay, which of the following statements are correct? So first we will draw one positive point charge of 10 to the minus 8 coulomb. So first we will draw the simple diagram and then we'll see what happens. So it is said that, okay, question number 5. There is one point charge of 10 to the minus 8 coulomb. So 20 centimeter away, there is one hollow sphere of radius 10 centimeter. So initially nothing is grounded. So I have to find out what is the potential here. So the option is given, the potential is 450 volt. Let us examine that is correct or not. So at distance 20 centimeter from the point charge, the potential of the sphere will be 10 to the power minus 8 by the distance, that is 0.2 meter, into 1 by 4 by epsilon naught, and the value of that is 9 into 10 to the power 9, that is volt. So 10 to the power minus 8 into 9 into 10 to the power, it will become 10 only by 0.2, so 90 by 0.2, that means 90 into 10 by 2, that is 450 volt. So the potential of the sphere will be 450 volt. So option A is correct one. Option A is correct. And now the sphere is grounded. So what is the meaning of the grounded? Grounded meaning the total potential of the sphere will become 0. Total potential of the sphere will become 0. See, total potential of the sphere will be due to the point charge, and as I am grounding it, there will be some induced charge on the surface. Let us say the induced charge is Q. So due to the influence of these two charges, the net potential of the sphere will become 0. So what is the potential due to 10 to the power minus 8 coulomb charge? That is already we have calculated, that is 450 volt. So 450 plus, due to the induced charge, some voltage will be there or some potential will be there. And what is that potential? 1 by 4 pi epsilon naught into Q by R. Here R is the radius of the sphere. So that ultimately will become 0. So 450 plus 9 into 10 to the power 9 into Q by 0.1 is 0. So Q I am getting, that is minus 450 into 0.1 by 9 into 10 to the power 9, that is 45 by 9, that is 5 into 10 to the power minus 9 coulomb. So I am able to see that the induced charge after it is grounded is minus 5 into 10 to the power minus 9 coulomb. What does that mean? So I have to examine option B, that is charge flowing from the sphere to the ground is how much? We have to calculate. So see, after it is grounded, the charge of the sphere is becoming negative. That means 5 into 10 to the power 9 minus 9 coulomb of charge is flown from the sphere to the ground. That is why it is right now negatively charged, or the induced charge is negative. So I can tell that option B, whatever is given, that charge flown from the sphere to the earth, that is 5 into the power minus 9 coulomb. So option B is also correct one. Now I have to examine the option C, and option C is after the grounding is removed, the charge of the sphere. Yes. So after this grounding, right now they have removed the grounding. So after this grounding is removed, the induced charge will still be that one only, minus 5 into 10 to the power minus 9 coulomb. So that option C is also correct. Now let us examine option D, that is Now this point charge is displaced by 10 centimeter away from the center of the sphere. Right now the distance of the point charge has become 30 centimeter from the center of the sphere. So right now what will be the potential? The potential will be due to the induced charge as well as due to the point charge. So due to the point charge, the potential will be 1 by 4 pi epsilon naught into q, that is 10 to the minus 8. By right now the distance is increased to 30 centimeter, that is 0.3, plus q, that is the induced charge, that is minus 5 into 10 to the power minus 9, by r is the radius of the sphere. That is right now the potential of the sphere. So let us calculate. 9 into 10 to the power 9, 10 to the power minus 8 by 3 will go 10. So 10 means we'll do 10 to the minus 7, minus 5 into 10 to the power minus 8. So that we have to multiply, that's it. So that is 300 minus 450, that is minus 150 volt. But the option given, that is 300 volt. So option D is not correct. So correct options are options A, B and C. So next question is question number 6, and that is given from geometrical optics, and let us read the question. Two identical concave mirrors, each of focal length f, are facing each other as shown in the schematic diagram. The focal length f is much larger than the size of the mirrors, that is okay. A glass slab of thickness t and refractive index n naught is kept equidistant from the mirrors and perpendicular to their common principal axis. A monochromatic light source S is embedded at the center of the slab on the principal axis as shown in the figure. For the image to be formed on S itself, which of the following distances between two mirrors is or are correct? So first we will draw the diagram. So there are two concave mirrors of focal length f are kept, let's say at some distance d away from each other, and exactly at the middle there is one glass slab of, not a glass slab but some slab of refractive index n naught is kept, and the thickness of the slab is t, and exactly at the middle there is one point source S is kept, and I have to find out the distance between the two mirrors if the image is formed on the object itself. Let us try to draw the ray diagram. Let us say here the point source is there. So light, let's say this mirror will examine, mirror 1 will examine this mirror. I will label it as mirror 2, and then let us send one ray like this. Now this ray is coming to this interface of n naught and the air medium. So what it will do? It will bend away from the normal. It will bend away from the normal. That means let's say it will bend like this. It will bend and go to the mirror like this. Then see, after the first refraction, the image that is seen to the mirror 1, that will be here. The mirror will not be able to see the object here, but rather for the mirror the object will be situated here at some other distance from the slab or air interface. Now what is the object distance? Actual object distance, that is t by 2 from one slab surface, t by 2. But as the light is bending away from the normal, it will appear, or after fast refraction the image will be appearing at lesser distance than t by 2. So what is the apparent distance from the surface to the object? Apparent distance will become t by 2 n naught, apparent distance. So right now, let's say from the slab to the mirror distance I have to calculate. What is the distance? This is d by 2, d by 2 minus t by 2. So this is d minus t by 2. Now see, this apparent distance or apparent position of the image, if it is situated at the center of curvature of this mirror, it will appear to be coming from the center of curvature of the mirror. In that case, the light will be reflected from this mirror, it will retrace the same path, and ultimately the final image will be formed on the object itself. So in that case, this distance should be the twice of the focus of one mirror. So this distance is, right now, distance is d t plus 2 n naught, this distance, plus this distance we have already calculated, that is d minus t by 2 plus d minus t by 2. That should be the apparent distance of the image after the fast refraction, should be at twice of the focus. This should be at twice of the focus. So let us calculate what is going to be the distance. So t by n naught plus d by 2 minus t, so d minus t is 4 into f, d is becoming 4f plus t minus t by n naught, so 4f plus t into 1 minus 1 by n naught. Okay, it is matching with option A, so option A is the correct answer. Now there can be another case, so this case will consider case 1. So let us examine another case in order to find out the another solution. Let's say this point object is not situated at the center of curvature, rather it is situated at the focus. In that case, what will happen? The same thing happen here, that ray will refract away from the normal. Then if it is situated at the focus, after that this ray will become parallel ray, it will come back to the second mirror, and then it will try to pass through the focus, but it will come here and ultimately it will form the image here. So that is also another case. In that case, the distance should be only focus, rather than being twice of focus, it should be only focus. So in that case, case 2, t by 2 n naught plus d minus t by 2 will be only focus, because we are considering not only one reflection but another reflection, again it is coming back to the same point, it is creating the image at the same point. So in that case, d will be 2f plus t minus t by n naught, so it will be 2f plus t into 1 minus 1 by n naught. That is the distance between two mirrors. So one option is this one, that is option A, and another option is option B. Yes, it is matching with option B. So two options are correct, A and B. So let us see question number 7. Question number 7. 6 infinitely large thin non-conducting sheets are fixed in configurations 1 and 2 as shown in the figure. The sheets carry uniform surface charge densities which are indicated in terms of sigma naught. The separation between any two consecutive sheets is 1 micrometer. The various regions between the sheets are denoted 1, 2, 3, 4, 5. If sigma naught value is 9 microcoulomb per meter square, then which one of the following statements is or are correct? And epsilon naught value is also given. So we'll draw the diagram. So this is configuration 1, we'll draw. First 1, 2, 3, 4, 5, 6. So region 1, region 2, region 3, 4, 5. This charge is plus sigma naught, minus sigma naught, plus sigma naught, minus sigma naught, plus sigma naught, minus sigma naught. And the value of the sigma naught is also given. I'll write down here. Sigma naught is 9 microcoulomb per meter square surface charge density, and permittivity value is given 9 into 10 to the power minus 12 farad per meter. That is okay. So first option we have to examine, that is in region 4 of the configuration the magnitude of the electric field is 0, it is given. So let us study that option. Okay, this region they have told what is the value of the electric field. Now see, this region right hand side the total charge is 0 and left hand side the total charge is 0. So this will be a electric field free region. Electric field free region. Similarly, another region will also be electric field free in this configuration, that is this region. See, right hand side total charge is 0, left hand side total charge is 0. So this is also a electric field free region. E field free region. So option A is of course correct option. And let me tell you that if the surface charge density of one plate is sigma naught, then and if it is infinitely large, then at any point here to the right the electric field will be sigma naught by 2 epsilon naught due to this plate 1. So in order to find out the electric field at this point, I have to take into account the contribution from all these plates. So to find out the electric field at this point, that is region 1. So let us now study option number C, because that is also related to the configuration number 1, because configuration 2 will study later. So potential difference between the first and the last sheets of the configuration 1 is 5 volt. So they are telling that the potential difference between this plate and this plate is 5 volt. Let us study. So to study that, let us find out the electric field in all those regions. So by now we have already found out that region 2 and region 4 is electric field free. So electric field in this region 2 is 0. Of course electric field at region 4 is also 0. So what will be the electric field in region 1? Electric field in region 1 will be due to all of these plates 1, 2, 3, 4, 5, 6. So due to the first plate, the electric field will be sigma naught by 2 epsilon naught towards right, because electric field is a vector quantity. Due to plate 2, the electric field will be also sigma naught by 2 epsilon naught, but that is also towards right because it is negative charge towards right. Due to this plate 3, it will be 2 epsilon naught, but it will be towards left. So ultimately this and this will cancel out. Due to the fourth plate, it is going to be sigma naught by 2 epsilon naught towards right. Due to the fifth plate, it is going to be sigma naught by 2 epsilon naught but towards left. So this is also cancelling out. And finally due to the sixth plate, it is going to be sigma naught by 2 epsilon naught, but that is towards right. So finally I am getting the electric field in this region 1 is sigma naught by epsilon naught. The electric field in this region is sigma naught by epsilon naught, but that is towards right. Similarly, I can find out the electric field in the region 3. In region 3, total charge to the left hand side is this one will be cancelling out each other. This one also will be cancelling out each other. So ultimately net electric field in this region 3 will be due to this one and this one, that is net will be sigma naught by epsilon naught towards right. Similarly in region 5 also same electric field we can calculate towards right. So let us find out the potential difference between plate 1 and the final plate, plate 6. So we'll find out potential difference dV, we know that is minus E dot dr. But here E is constant throughout the region 1, E is constant throughout the region 3, E is constant throughout the region 5, region 2 and region 4 electric field free region. So total delta V, that is going to be minus of sigma into epsilon naught into d. D is the distance between two plates 1 and 2, first two plates d. Again sigma naught by epsilon naught into this distance, that is d, again into sigma naught by epsilon naught into this d. So it is becoming 3 sigma naught by epsilon naught into d, that is delta V, and delta V is V2 minus V1. So what does that mean? V2 minus V1 is minus 3 sigma naught d by epsilon naught means V1 minus V2. That means this plate, the plate number 1 is at the higher potential. It is becoming 3 sigma naught d by epsilon naught. So to find out the potential difference, let's put the values. So 3 into sigma naught is given 9 into 10 to the power minus 6, that is 10 to the power minus 6 meter, by epsilon naught is given 9 into 10 to the minus 12. So this will ultimately cancel out. It's becoming 3 volt. Delta V is becoming 3 volt. But in our option it is given 5 volt. So option C is not the correct one. The correct will be 3 volt. So right now we have studied configuration 1, all those options, 2 options are given from configuration 1. We have studied those 2 options and we have found out that option A is the only correct one. Now let us study the configuration number 2. So why I am erasing this? Okay, let me. Configuration 2, everything will be similar, only except the first and the last plate charge is half, that's it. 1 2 3 4 5 and 6. So first plate charge will be sigma naught by 2 plus sigma naught by 2, of course. Second one minus sigma plus sigma minus sigma plus sigma minus sigma naught by 2. Distance between two plates d, that is constant. D I'll write down here or else I'll forget. Micrometer. So I have to examine 2 options. Let us study the first one. In region 3 of the configuration 2, the magnitude of the electric field is sigma naught by epsilon naught. Now let us study the region 3, that is 1 2 3 4 5. Let us study the region 3. See, region 3, right hand side total charge is not 0. At the same time, left hand side total charge or charge distribution is not 0, is non-zero. So electric field will not be 0 here. Okay, that is one thing we can get. Now they have given that electric field is sigma naught by epsilon naught. Now let us find out. So see, out of this right hand side total charge, these two charge, due to these two charge or two charge distribution, the electric field will cancel each other. So electric field only be due to this one. So electric field in this region due to sixth plate is going to be sigma naught by 2 by 2 epsilon naught, but it is towards right, in this region electric field will be due to the left hand side charges also, but in the left hand side charge, among these left hand side charges, these two charge electric field will cancel each other. So ultimately net electric field due to the left hand side charges will be only due to this charge sigma naught by 2. So that is going to be sigma naught by 2 by 2 epsilon naught, that is also towards right. So total electric field will be this plus this, that is sigma naught by 2 epsilon naught towards right. But in the option it is given sigma naught by epsilon naught only. So this option is also not right. The option number B is also not right. Option number B is not also right. So right now only one option we have got right, that is A. Now the final option we have to study, that is option number D. it is given that the potential difference between the first and the last sheets of the configuration 2 is 0. So again, you have to calculate the potential difference between plate 1 and plate 6. Now see, in this region we have got the electric field is sigma naught by 2 epsilon naught towards right. Now let us study region wise. Region number 1. Region number 1, total charge to the right of the region number 1 is sigma naught by 2 only. So other these things will cancel each other. So net electric field in this region will also be due to this charge and this charge distribution, and that we have already calculated, that is sigma naught by 2 epsilon naught towards right. Again, region number 2. Region number 2, net charge to the left hand side of region 2 is becoming minus sigma naught by 2. So total addition of these two, it will ultimately give minus sigma naught by 2. And total charge to the right hand side of the region 2 is going to be this one plus this one plus this one plus this one. It is going to be plus sigma naught by 2. So net charge to the right hand side of region 2 is becoming plus sigma naught by 2. So net electric field in this point will be due to this one but towards left, for this one also towards left. So it is going to be sigma naught by 2 epsilon naught total, but it is towards left. It is also towards right. Again, in this side also will get towards left, that is sigma naught by 2 epsilon naught. And this plate also will get, because it is symmetrical, so sigma naught by 2 epsilon naught towards right. So see, to find out the potential difference, delta V is minus E dot dr. So this region E dot dr is going to be sigma naught by 2 epsilon naught into d. Minus, of course, minus. This one, it is already a minus, so minus sigma naught by 2 epsilon naught into d. Again, minus sigma naught by 2 epsilon naught into d. Minus of minus sigma naught by 2 epsilon naught into d. Again, finally, minus sigma naught by 2 epsilon naught into d. So ultimately, which ones are cancelling each other? This one is cancelling out, this one is cancelling out, this one is cancelling out, this. So ultimately, it is becoming sigma naught by 2 epsilon naught into d minus of that, so delta V. So V1 minus V2 is becoming sigma naught d by 2 epsilon naught, and if I put all those values, okay, let us put those values. 9 into 10 to the minus 12 into 10 to the power, sorry, I'm going to 6 to the minus 6 by 2 into 9 into 10 to the power minus 12. So this is cancelling out, 9 is cancelling out. So it is becoming 0.5 volt. So V1 minus V2 is becoming 0.5 volt, but in the option is given that V1 minus V2 is 0 volt. So option D is also not correct. So only correct option is option number A. Now let us discuss the last question in section 2, that is question number 8. It is from thermodynamics. It is given that the efficiency of a Carnot engine operating with a hot reservoir kept at temperature of 1000 Kelvin is 0.4. It extracts 150 joule of heat per cycle from the hot reservoir. The work extracted from this engine is being fully used to run a heat pump which has a coefficient of performance 10. The hot reservoir of the heat pump is at temperature of 300 Kelvin. Which one of the following statements is or are correct? So let us draw the Carnot engine cycle that is operating between two temperatures. Question number 8. It's this is one Carnot engine cycle, Carnot engine. So there must be two temperature. One is the hot reservoir, another is the cold reservoir, that is a sink. This temperature of the hot reservoir is given 1000 Kelvin. Efficiency of the Carnot engine is given 0.4. So that means the Carnot engine will ultimately take the heat from the hot reservoir. Let's say this heat is Q1. It will reject some heat to the cold reservoir, and by doing that it will give some work output. And this work output is fed to a heat pump. Now what is the function of the heat pump? Function of the heat pump is to pump heat. But in that operation, what this heat pump will do, it will extract the heat from the cold cabin and it will throw out some more heat to a hot cabin in order to keep that hot cabin hot. So it will throw out some heat in order to keep one place warm. That also we can tell. So let us say hot cabin, and it will ultimately extract the heat from a cold reservoir or cold place. Let us assume it is cold place. Let us tell this cold place. So let us assume that from the cold place, heat pump is extracting Q3 amount of heat and ultimately it is throwing out heat in the hot cabin to keep the place warm, that is Q4. And for doing it, it needs some work input. To constantly run the heat pump, it needs some work input. So let us study the option A, is work extracted from the Carnot engine in one cycle. It is given that this Carnot engine extracts 150 joule of heat from the hot reservoir. So what will be the work output? So what is the efficiency of Carnot engine? Efficiency of the Carnot engine is 1 minus temperature of the cold reservoir by temperature of the hot reservoir, T2 by T1. And what is that? Ultimately that is 0.4, that is only given 0.4. So 0.4 is becoming 1 minus T2 by T1. And what is the meaning of the efficiency? Meaning of the efficiency is how much work output it is able to give for 150 joule of heat extracted from the source. That means work output by heat input, that is Q1, that is 0.4. So what is the work output? Heat input is already given 150 into 0.4, that is 60 joule. So 60 joule will be the work output of the Carnot engine, 60 joule. So option number A is correct one. Is the correct one. Now option number B, will see temperature of the cold reservoir of the Carnot engine is 600 Kelvin. So it is given that 1 minus T2 by 1000, that is 0.4. So T2 by 1000 is going to be 0.6. So what is the value of T2? 600 Kelvin. So option B is also correct. Option B is also correct. Now let us examine the option C. Temperature of the cold reservoir of the heat pump is 270 Kelvin. Now this temperature I have to find out. Let's say this is T3. I have to find out. Now what is the coefficient of performance of the heat pump? That is given 10. And what is the meaning of the coefficient of performance? That means what is the function of the heat pump? To keep one place warm. To keep one place warm, that is the function of the heat pump. So what is the expected output from a heat pump? Expected output is heat given to the hot cabin. That is our expected output. So expected output is Q4. And what is the input? Input is W. It is the work input is given to the heat pump to keep the heat pump running. So that by W is the coefficient of performance, 10. Now Q4 by W, we have already seen that it is 10. Now what is the relation with temperatures and what is W? See, if we apply the first law of thermodynamics here, total energy input is W plus Q3 and total energy output is Q4. So we can write that Q3 plus W will be equal to Q4. So W I can write Q4 minus Q3. So easily I can write from here, that is Q4 by Q4 minus Q3, that is 10. And this will be proportional to the temperature of that hot cabin, and Q3 will be proportional to the temperature of the cold place. So we can directly write from here that T4 by T4 minus T3 is 10. T4 is already given 300, so it is 300 minus T3, that is equal to 10. So we can write that 30 is equal to 300 minus T3. So T3 I am getting 270 Kelvin. That is option C. That is also correct option, because it is given that the temperature of the cold reservoir of the heat pump is 270 Kelvin. So this is also correct option. Now we'll examine option number D. Option number D is heat applied to the hot reservoir of the heat pump in one cycle is 540 joule. That we can directly find out from COP, and COP is given 10. And what is the COP I told? COP is expected outcome by the energy input. What is the expected outcome of a heat pump? Expected outcome of a heat pump is to how much heat it is able to send to the hot cabin, that is Q4, by how much energy you are giving as the input, that is our work extracted from the Carnot engine, that is given 10. So Q4 is 600 joule ultimately I am getting. But it is in the option, it is given that heat supplied is 540 joule. So option number D is not correct. Correct options are options A, B and C.